So chapter 4.6 is on systems of linear equations with three or more variables. So an example of this system would be this, where we have 2x plus 3y minus z equals negative 1, negative x plus 5y plus 3z equals negative 10, and 3x minus y minus 6z equals negative 5. And these three planes will intersect in a single point. And they're three linear equations that have three different variables, and so they intersect in a single point with one ordered pair, x, y, and z, that will satisfy all of these equations. And so we are going to solve this very similar to how we would solve a linear system with two equations and two variables. But in order to do that, first we have to get it into a form similar to that. So the first step is to eliminate a variable in two of the equations. So the two equations here are the first two equations from the step before. And so what we're going to do is we're going to eliminate the x's. So in order to do that, we multiply this second equation by 2. So then we get negative 2x plus 10y plus 6z equals negative 20. And we'll rewrite this first equation even though we're not changing it. So 2x plus 3y minus z equals negative 1. So we will add these two, so we'll get 0x plus 13y plus 5z equals negative 21. And we will save that equation for later. So step 2 is to eliminate a variable in different equations. And so these two equations are the second and third equations from the original system. And so what we will be doing is we'll be multiplying the first equation by a 3. So I'll just reprint it right below. So negative 3x plus 15y plus 9z equals negative 30. And then we'll add these two equations to get 0x plus 14y plus 3z equals negative 25. And so we had to eliminate the same variable. So in each equation we eliminated x. So that now we have two equations that have only two variables. And so now we can linearly combine these two just as how we would with a regular equation. So we'll multiply this first equation by 3, this bottom equation, by 5, so that we can eliminate the z's. So the first equation will transform into 39y plus 15z equals negative 63. And this bottom one will be 70y plus 15z equals negative 125. And we are going to subtract the second equation. So then we would get negative 31y plus 0z equals 62. So then divided by negative 31, so y equals negative 2. And that is the first answer for our ordered pair. Step 4 is substituting the value, and the value we have is y equals negative 2. So we will plug that into the equation of 13y plus 5z equals negative 21 to get 13 times negative 2 plus 5z equals negative 21. So negative 26 plus 5z equals negative 21. Move the 26 over, so 5z equals 5. So z equals 1. And that is our second value for the ordered triplet. And the final step is to substitute the two values in. And two values are y equals negative 2 and z equals 1. And we'll plug that into the equation of negative x plus 5y plus 3z equals negative 10. So we'll get negative x plus 5y, so negative 2, plus 3z, so 3 times 1 equals negative 10. So simplifying that out, so negative x minus 10 plus 3 equals negative 10. So negative x equals negative 3, so x equals 3. So we have our three values of x equals 3, y equals negative 2, z equals 1, giving us our solution of the ordered triplet 3, -2, 1. And that is how you solve a linear equation that has 3 or more variables.